What's up, everybody? Mickey Gaminal here. This is going to be my first lesson of a 20 lesson course. This lesson is all about the 3 easy points. So every time you're taking the math knowledge or arithmetic reasoning, anytime you see any of these 3 questions, I want your eyes to light up. I want you to be excited that you're going to get these questions right. So these 3 sections are going to be all about getting those easy points so that you can get your score up out of like single digits, or if it's pretty high but you've been missing something, this can lower it drastically. So simple things like exponents, factorials, and scientific notation, if you're missing those 3 things, this is going to be the video you want to watch, because those questions should be super simple, and if you're missing those, you're leaving points on the table. So let's get started. Hi, everybody. We are going to be working on exponents first. Exponents are pretty straightforward. What you're using is, so an exponent is like multiplication, but it's bigger, right? So what you think of when you think of exponents, like a number to a third power or something like that, that number is going to be multiplied by itself that many times. So exponents are like multiplication, but the numbers will grow faster. So if we think, it's kind of like addition is to multiplication, multiplication is to exponents. So like 3 plus 3 plus 3 is equal to 3 times 3, right? Because I have 3 3's there. And so 3 times 3 is going to be the same thing as 3 plus 3 plus 3. But now what I want you to think of is 3 times 3 times 3 is equal to 3 to the third power. That's what an exponent is. Exponent is saying multiply the base by this number of times. So if it's 3, well, we'll get away from 3's for a second. 6 to the 5th power, I'm going to draw 6 or 5 6's times itself. Cool. So 6 times 6 times 6 times 6 times 6 is going to give me 6 to the 5th power. That's what an exponent is. So knowing that definition, you can actually do quite a bit. So if you ever see something like x to the 3rd power over x to the 2nd power, and you're like, holy cow, now there's letters, I don't know what to do, just take a deep breath. It's just how many times are you multiplying the number by itself? So you can expand this by saying x to the 3rd power is going to be x times x times x divided by x to the 2nd power, which is x times x. And what's really cool about this is you can factor. And so when you factor these out, you just get x by itself. So x over 1, anything divided by 1 is just itself. So that's what you guys want to start thinking of. Don't be too intimidated by exponents. It's just going to be factoring. So anytime you have b to the 6th over b to the 4th, that's going to be b to the 2nd. And how did I do that so quickly? I just subtract this one from that one. So x to the 3rd over x to the 2nd, that's x to the 1st, which is x times itself just once. So x not times itself. So just x is the same as x. So that's the idea. Any number to the 1st power is just that number. Any number to the 2nd power is going to be that number times itself twice. And any number to the 5th power is going to be that number times itself 5 times. Cool. So hopefully that will help you whenever you see these exponent questions. So let's get into a few of them. A couple examples are going to be 3 to the 4th times 3 squared, 3 to the 4th divided by 3 squared, which could also look like this. 2 to the 3rd. I used 2 to the 3rd to make an example, so go ahead and solve what 2 to the 3rd would be. And then lastly, to get a little bit crazy, 2 to the 3rd to the 2nd. And I know that's something we haven't gone over today in class, but I want you to try it. I want you to go through, give that last one your best shot, kind of make a guess to how it would work. So these two are the same. Remember that that division symbol is the same as that division symbol. So those are both mean divided by. So 3 to the 4th divided by 3 to the 2nd. So go ahead, you can pause it here, take a little bit of time, try to figure these ones out, and then I'll go through and show you how to do it. Hopefully these make perfect sense. And if they don't, let me know and I'll see what I can do to help you. All right. 3 to the 4th times 3 squared. Well, here it's going to be 3 to the 6th. So remember, when we divided, we subtracted. So now when we multiply, we're going to add. And the way I can prove this to you is to expand it. So 3 times 3 times 3 times 3. We'll let this one be yellow, and then we'll have this one be red. And then, of course, black multiplication sign in the middle. So times, then red, 3 times 3, right? Because 3 to the 2nd power is 3 times itself. 3 to the 4th power is 4 3s all times themselves. And how many 3s is that altogether, guys? It's 6. 3 to the 6th power. So you can just say 3 to the 6th power, or you can go through, multiply, and solve for it. It's probably not impossible. So it looks like we have 9 to the 3rd power now. Now it's getting kind of crazy, right? 81 times 9, because 9 times 9 is 81. Then multiply that by the last 9 here, and what do we get? 972. So 729 is the correct answer, but the answer you're going to see on the ASVAB is probably going to be that factored answer there, the 3 to the 6th. So keep that in mind. A lot of times the ASVAB is going to check to see if you can simplify these concepts, especially when it comes to exponents. We'll just do 3 to the 4th divided by 3 squared. Hopefully you guys remember this from what we practiced earlier. You're just going to subtract them, right? 3 to the 4th times 3 squared equals 3 to the 2nd, which is also known as 9, or 3 times 3. But again, let me do the same thing. I'll do this divided by sign, and then I'll do this one in red, this one in yellow. So in yellow, we have 3 times 3. In red, we have 3 times 3 times 3 times 3. And what factors out here? So 3 divided by 3 is 1. 3 divided by 3 is 1. So those two are just 1 times 1, which doesn't change anything. And so what we're left with is 3 times 3, also known as 3 squared or 9. Either one of those is fine. Cool. Hopefully the gears are turning. Hopefully you're able to get this one right, because we did kind of cover that one in the initial example. All right, so that one's done. That one's done. Let's do 2 to the 3rd. 2 to the 3rd. This one's really for those of you who have been like, oh, I don't know what to do. This one is to help give you a little bit of confidence, where it's like, you don't know what to do yet, but you know what to do with this one. Hopefully you're going to multiply the base this many times. So 2 times itself 3 times. 2 times 2 times 2. And so hopefully you guys can figure these out. What's 2 times 2? Well, 2 2s makes 4, and times it by another 2, and we get 8. 2 to the 3rd power equals 8, and that's always going to be true. Cool. So hopefully that one was a little bit simple. And the last one, ooh, crazy one. 2 to the 3rd to the 2nd power. You guys are going to love this. So 2 to the 3rd, we'll do that one in red, and then we'll figure out what to do with this yellow one. But it's not that crazy. It's not that complicated. What you end up doing is multiplying. 3 times 2, you get 2 to the 6th. But let me prove it. So in red here, we have 2 to the 3rd. So 2 times 2 times 2. And then outside the parentheses, we have in yellow to the 2nd power. Now, what does this mean? It means we have to multiply whatever this is by itself 2 times. So we get 2 times 2 times 2. And then for the second one, 2 times 2 times 2. And how many 2s is that all together, guys? 3, 6. And that's where that 2 to the 6 comes from. So the shortcut, just multiply these. But the expression, right, the way that you can solve it is to expand it and then solve. And that's going to be a lot of things with math. A lot of times with these math questions, they're checking to see if you understand the concept. So keep that in mind. We can solve for 2 to the 6 real quick. This isn't too bad. 2 times 2 times 2 times 2. So we remember from the last question that 2 to the 3rd power was 8. And so we can just do 8 times 8. because we're super math geniuses like that. So hopefully you guys like this video. Hopefully the exponents are super clean now, super clear for you, and you're ready to move on. I will be having some worksheets attached near this video if you're on my actual course. If you're not on my actual course, there should be a link to the course somewhere nearby. So let's go through. Next up, so exponents, we're pros now. We got that one taken care of. We got that one taken care of. If you have questions about exponents, you can always watch more videos, of course, but just get more practice, right? So a good worksheet with this, a good quiz, whether that's online or through my stuff, totally fine. Let's do factorials. Ooh, I love factorials. So anytime you see this, if you're guessing, you are leaving points on the table. You should not guess when you see this. All this means is you take the number and multiply it by the next one down, all the way down to 1. But of course, anything times 1 is itself, so we don't really worry about 1 once we're pros. But you can always multiply it by 1 if you want. And that's it. Every time you see, if you see a 3 factorial, it's going to be 3 times 2 times 1. If you see a 26 factorial, well, now things get crazy, right? Because it's going to be 26 times 25 times 24, times 2 times 1. So everything times the number above it, okay? So 6 factorial, I'm not going to answer 26 factorial because that's not going to come up on the ASVAB, but 6 factorial, you can do 30, 4 times 3, 12, 2 times 1, 2, 12 times 2, 24, 24 times 30. I'm going to stack them and go through. So 4 times 0 is 0, 4 times 3 is 12, 2 times 0, we shift over because now we're timesing by the tens place. We shift over. 2 times 0 is 0, 2 times 3 is 6. Add those up and we get 720. So 6 factorial equals 720. 3 factorial is just going to be 3 times 2, and then times it by 1 if you want. But 3 times 2 is 6, and so 3 factorial is 6, 6 factorial is 720. Where you might see something crazy is if you see something like this, 26 factorial over 24 factorial. Again, same idea as exponents. You can cancel a lot of this out. So remember, 26 times 25 times 24, and then it's going to go 23, 22, 21, 20, right? Forever. So what we can do is we can do this part, leave that out, and then say that's 24 factorial. And now check that out. Boom, that cancels to 1. So now all we have is 26 times 25. Love it. Super easy. Nothing crazy here. 5 times 6, 30. 5 times 2, 10. Plus 3, 13. Shift over because now we're multiplying by the tens place. We're timesing by 20s, not by 2s. And so 2 times 6 is 12. Carry the 1. 2 times 2 is 4. Plus 1 is 5. Add that up. And we get, what is this? 650. 650 is the answer for this question. That's if there's a factoring one with factorials. You're not likely to factor factorials on the ASVAB. But if you do get a question like that, it probably means you're killing it, because this is what's considered a higher level skill. The factoring is considered a higher level skill on the ASVAB, which means your math scores are going higher. I'm good with that. I got a couple of practice questions here, so let's go through those. 3 factorial, we already did that one. 3 factorial over 2 factorial. We'll see what happens there. 5 factorial times 3 factorial. And lastly, 7 factorial. Oof, the 7 factorial I just did to be a monster. All right, so go through. You can pause it here, work through those if you want. I'm going to get started. So 3 factorial is going to be 3 times 2 times 1, which equals 6. That one's a check. Easy money, right? 3 factorial, we know is 6. 2 factorial, we know is just 2 times 1, or 2. And so 6 divided by 2 is 3. But what we could do instead is we could draw these all the way out. 3 times 2 times 1, 2 times 1, and we could cancel out, and we'd still get that 3. Check that out. Cool, right? 5 factorial times 3 factorial. Well, we know 3 factorial again is 6. And 5 factorial is going to be 5 times 4 times 3 times 2, which again was 6, right? So now we have to do 6 times 6 times 5 times 4. And the cool thing about these math questions is you can use the cumulative property. So anytime you have multiplication and it's just multiplication, you can do it kind of out of order. The reason for that is because 3 times 5 equals 5 times 3. It's called the cumulative property. 3 5s is the same as 5 3s. But let's go through. We'll do it in order just to keep it simple. 5 times 4 is 20. 6 times 6 is 36. And then I'm just going to stack them up. 36 times 20. I love putting 20s in the bottom because 0 times 6 is 0. 0 times 3 is 0. And then you shift over because now you're timesing by the tens place. 2 times 6 is 12. And 2 times 3 is 6. Plus 1 is 7. Crazy. 720. I feel like we've been seeing a lot of 720s here. All right. 7 factorial. That one's a monster. Let's do it. So we did learn that 6 factorial, if we'll recall earlier, was 720, but it's all good. This isn't impossible, right? And that's the important thing. Once you know the rule, you want to remember that you can do it, right? Whatever number I put out in front, it's going to be a pain if it's like 76 factorial, but it doesn't mean that you can't do it. It definitely can be done. Now I'm going to do it out of order. So I'm going to do 7 times 2, 6 times 3, and 5 times 4. 7 times 2 is 14. 6 times 3 is 18. 5 times 4 is 20. And then I'll stack them, I guess. I mean, 20 times 18 is pretty easy because it's just like 2 times 18, which is 36 with a 0. So I'm actually going to shortcut it there. Again, these shortcuts, you only want to do them when you know what you're doing. So I knew that I had to double 18, which I already know is 36, and add a 0 because it's not times 2, it's times 20. So 20 18s makes 360. And last, 360 times 14. Here we go. 4 times 0 is 0. 4 times 6, 24. 4 times 3, 12, plus 2, 14. Then shift over because we're timesing by a tens place. We're not timesing by 1, we're timesing by 10, the 10 on the 14. And then 1 times 0 is 0. 1 times 6 is 6. 1 times 3 is 3. And then 0, 6, add those two together. 4 plus 0 is 4. Carry the ones. 4 plus 6. And 5. 5,040 is the answer. Cool. Not a picnic, but not impossible. Remember, for the math knowledge, you have about a minute 30 for every question. And then for arithmetic reasoning, you almost have 4 minutes per question. So even though I talked through it and it might have taken a little bit longer, it's worth getting that extra point right. So I think and getting a question right and knowing that it's right, you feel much more confident going into the next question. So it's going to make things easier. All right, last thing, scientific notation. Cool. So this will come up on math knowledge, arithmetic reasoning from time to time, but you may even see this on general science, and which is great, right? Because now you're getting points for studying math that you can apply to general science points, and that's going to raise your GT score. It's going to give you that military job of your dreams. So let's go. Scientific notation. I got a couple examples. This is a lot easier to explain with examples, but the idea is scientists, they use really, really big numbers and really, really small numbers all the time. And the way that they make that simple, rather than writing something crazy like, well, I got an example here, 20,932, right? It's a pretty big number. What they'll do is they'll simplify it. So they round it to like money, right? They round it to the 100th. So they'll round it to like 3.14, something like that. And then they'll times it by 10 to whatever number, right? They're using exponents to make their lives easier. And that's what math is for, guys. The thing is, we forget this. Math was invented to make our lives easier. So they use scientific notation to make it so that they can write numbers in a smaller space and still be fairly clear. So here we go. For this one, if I wanted to turn this into a scientific notation, I would need to move this decimal point here a certain number of times. And you guys know, because you're super smart math folks, that 3 times 10 equals 30. 3 times 100 equals 300. 3 times 1,000 equals 3,000. And so on and so on. And so the same idea here, but instead what we're doing is we're saying 10 to the first power, 10 to the second power is 100. 10 times 10 is 100. And 10 to the third power is 1,000. So 3 times 10 to the third power is still 3,000. If I have 3.71 times 10 to the fourth and 3.71 times 10 to the negative fourth. In this one, this is going to be a very big number. So this is going to be the weight of the ocean. And this one is going to be a very small number. This is going to be the number of grams of acetaminophen in Tylenol or something like that. I'm not a nurse, so don't tell my wife that I think acetaminophen's in Tylenol. All right, so let's go through. 3.71 times 10 to the fourth. We're going to make this number bigger, right? Because this is a positive 4. So it's going to go 1, 2, 3, 4. We're just going to fill in zeros. And so the answer is 37,100. That's equal to that. 3.71 times 10 to the negative fourth. This is going to become much smaller. And so we're going to go smaller to the negative fourth. 1, 2, 3, 4. We fill in with zeros. And then we also want to put a 0 out in front, because we don't just want to say like 0.36 cents, something like that. You want to say $0.36. It's kind of why you throw that 0 out. What we end up with is 0.000371. Cool. And this one's really good for just practice, right? If you get some practice with this one, you can really get it down. The factorials and the exponents, there's going to be some high level questions that might make things harder. But this one is really just 10 to the whatever. So let's go through these practice examples. So 3.14 is pi, right? It's used for figuring out the area and circumference of circles. So that's why I picked those numbers. And then I picked these numbers because this one's Dogecoin. I checked out to see how much it's worth when I was writing this lesson. And so Dogecoin in scientific notation, and then BTC, which is Bitcoin in scientific notation. You may recognize this one. So let's go through. 10 to the third is going to give us a bigger number. So 3.141 is going to go 3 times to the right. 1, 2, 3. And we get 3,141.0. But you don't need to put a point if it's just 0. Just like $5 is equal to $5. You don't really need those zeros there if it's just ending at the 1 without anything after the decimal. All right, let's check this one. 3.14159, 10 to the negative third. 10 to the negative third, the number is going to get smaller, right? To the negative third. So we're going to move that decimal to the left. 1, 2, 3 times. And we get 0.00314,159. And usually you would just stop it after 3 numbers. It's usually good. Dogecoin. So what we can say about Dogecoin, if we wanted to turn that into scientific notation, we would say, okay, how many times are we moving it? 1, 2. And it's a very small number, so we're going to use 10 to the negative 2. And we get 8.1 times 10 to the negative 2. All right, because this number is much smaller. So 0.081 is a very small number. That's why it goes 10 to the negative 2. Here we have a very large number. We need to move this decimal 1, 2, 3, 4 times. Oh. 1, 2, 3, 4. Yep. So 4 times here. And we find ourselves with 2.09 times 10 to the fourth, because it's a very large number, $20,000 for 1 Bitcoin. So that is it. Get some scientific notation practice from my course. If you have any questions, let me know. Reach out to me, hit me in the comments, shoot me direct messages. I'm really excited, and I hope you guys enjoy my course, and I hope you like my shirt. All right, guys. Have a great day. Hopefully this really improves your ASVAB score, because missing these simple questions is really what gets people down. You know, if you're missing simple questions like that, it may take you from a 15 down to a 9 or something like that. So don't want to be missing those easy points, because those can really have a big impact. All right, guys. Hope everybody's having a great day, and remember to be kind to yourself. See you guys.